Okay, you guys weren't kidding when you said that the audio quality of the previous attempt was really bad. So here goes attempt number 2. Hopefully this goes a little bit better. So for this one, we'll be talking about responses to acute heat stress. So here are the 3 objectives. All right, and so to start off, when it comes to heat and the cardiovascular system, there's a couple of demands that the body has to meet. And when we're exercising, that kind of adds to it. And so we want to think about this in terms of exercise and the heat. And so we have to get oxygen to the working muscle, and then we have to increase skin blood flow to dissipate heat. And so if you think about this, these are conflicting demands, because if we've got blood going to our skin, that means it's not going to the working muscle. And so that's going to make it more difficult for us to exercise. So how does this work? Well, like I said, we have less blood that goes to the active muscle. As a result, that means there's decreased venous return, which means stroke volume is less and heart rate is higher. Okay, so this decreased blood flow to the active muscle due to the increased, let's see, so I'm going to put SBF here, so skin blood flow. All right, that could potentially lead to this decreased stroke volume. Now, we'll talk later on that it might actually be increased heart rate that's decreasing stroke volume, or it could be decreased stroke volume leading to an increased heart rate, and we'll get into that. But regardless, we end up having a higher cardiac output, a higher than normal cardiac output for a given workload. Okay, and so what happens is we hit a VO2 max at a lower intensity. Now, the VO2 max, not only is it occurring at a lower intensity, but the value itself is lower. And so if your VO2 max is 50, in neutral temperatures, we put you in the chamber and then we have you do a max test when it's 125 degrees in there, your VO2 max might be 10 or 15 or 20% lower. Okay, just because you're not able to meet both of those demands. All right, so, and this ties into steady state. Remember, whenever we're doing an activity, it requires a specific amount of oxygen. Okay, that doesn't matter really if we're exercising the heat or not. It's just you do an activity, it requires a specific amount of oxygen. Now, the heat changes that, or changes things a little bit, because we're sending more blood to different places, right? So we're sending more blood to our skin. All right, and the problem, or one of the problems, is that heat, like it says here, causes heart rate to really never reach a steady state, and it leads to something that we call cardiovascular drift. Now, I want you to take a minute and look at this figure here. So we've got 5 different variables. We've got time on the x-axis. We've got the change from 10-minute values on the y-axis, and this is a percent change. Now, the reason that they wait until 10 minutes is because they're trying to see what steady state is, because it can take that long. And so notice that cardiac output remains relatively constant. Blood volume remains relatively constant, but it's decreasing a little bit because you're losing plasma volume due to sweat. But pressure drops, and so does stroke volume. Okay, and the pressure drop isn't a huge surprise. When you have whole body exercise, you dilate the vessels to your active muscle, so that's not a surprise. But what's challenging is that we hit max, or that our heart rate increases so rapidly. Like, there's never really a consistent value. And this is what we refer to as cardiovascular drift. And so during prolonged steady state exercise, heart rate increases and stroke volume decreases. So why does this happen? Okay, well, there's a couple of theories behind this, and if I'm being honest, I think it's a combination of the two, but I think that there's one that's more dominant. But that's science according to Dr. Davis. We still haven't figured that out completely. So the first theory is that skin blood flow, if we have high skin blood flow so we can dissipate heat, so we can produce sweat, that decreases the amount of blood that's going back to my heart. As a result, there's less preload. With less preload, there's less stroke volume. Okay. The other thing is that heat just in and of itself might increase heart rate. We know that heat speeds up chemical reactions. We know that heat speeds up nervous system signals. And so it could just be the fact that heart rate is increasing, which causes a decreased filling time. If I have less filling time, that could decrease stroke volume. Now, me personally, I tend to think that 1 is the primary reason that we have cardiovascular drift, but I think 2 also plays into it, that eventually you get to this point as well where just the heat speeds up your heart rate anyway. And so that causes a decreased stroke volume. All right. And so really when it comes to acute responses, we're having to deal with the fact that increased skin blood flow takes blood away from the active muscle, and that makes it so it's more difficult to exercise.